Hi. Okay, I'm going to change the format a little bit different for the last little part here. So this is our third part of our materials. So again, this covers just the main ones which we need to know for the exams and for any questions and such, not everything inside out. So obviously when I do get you back into the classroom for a period of time, we will spend a bit more time doing this. This is just to get the basics, some of the basic knowledge in. The last thing we're going to look at are plastics. Okay, so let me just manage to get the wrong slide there. Plastics. Plastics are one of the things which are around us everywhere. Everything that we use these days tends to be more made from plastic. Why? There are a number of different reasons. If you think back to probably gran and granddad time, most of the things which were around the house were made of wood, they were made of metal. There was some things made of plastics around about the 50s, 40s and 50s. Plastic's been around for a while, but not in a manner which was easy to use. So as plastics have evolved, essentially by people playing around with what goes into them, how they manipulate them, the different types of plastics that they've come up with, additives and stuff, this is what's allowed us now to have pretty much everything that we use has some form of plastic in it. And that's the difficult bit, because there are so many different plastics and so many different ways of changing them. So there can be two plastics which are identical to each other but are totally different in terms of how they actually feel. One can be soft. PVC, there's a good example. PVC can be a soft material for clothing. You use it, previously it used to be like a fake leather, but PVC can also be really hard in terms of the gutters that's sitting around about your house. So the same material, but just what you add to it makes it different. So plastics can be a little bit more difficult. So we'll try and keep it fairly simple just by limiting the amount of plastics we're looking at, and what I'm going to try and tell you. It's much easier to do face to face and physically with plastics in front of us. This is why I've got a box of lots and lots of products that we'd actually look at and physically touch, look at the uses and think about what the plastics are for them. So now plastics are a lot cheaper. They're a lot cheaper to manufacture than something with metal. They have good properties in terms of their weight. They have properties in terms of strength, how reliable they are in terms of longevity. So, where some things in metal or wood might give up after a while. We call this durability, an overused word, but they will last longer. So plastics are there. They're there because they're cheap, they're there because they last better, they're there because they're easier to manufacture. You think about some of the complex shapes of some of the products that we have. It's easier to mould a plastic into that shape than it is to try and physically take a piece of wood and make it into that. Those who've been through woodwork will know the exact difficulties of trying to make a piece of wood look like something different. It's not that easy to do, especially if you're doing it by hand tools. So when we talk about plastics, this takes us back to first year. We always taught you about plastics in first year. Two families of plastics, thermoplastics and thermosetting plastics. So we'll do the thermoplastics first. Essentially, plastics come in a granular form. Some of that granular form comes from a big factory there at Grangemouth, the Exxon factory. They create plastics for the industry. So they're oil-based. And once we add different things to those basic granules, this is when we actually create the different types of plastics. And by using heat, that is one of the main constituents of getting a plastic to do something. By adding heat to it, you are effectively melting all these little grains that you see there on the screen. So effectively a thermoplastic is one which allows us to heat up the plastic, and once it's cooled, we can use it as it is, or if need be, if there's been an error or something's not quite right, we can take it, heat it again, and then it will return back to its original form. Not the granules, but its original shape. So if I gave you a flat sheet of plastic, heated it up, bent it in the oven, and we would be doing this in the workshop, by the way, heating it up, bend it, let it cool, don't like it, back in the oven, heat it up, and it'll come back out as a flat sheet again. So it can be quite useful. Thermoplastics are probably the widest used plastics around because of that. And the good thing with that, it does mean that thermoplastics are easier to recycle than other kinds of plastics. So that's all you really need to think about a thermoplastic. If someone said something to you, right, describe a thermoplastic, one which can be heated repeatedly more than once, and it will return back to its original shape each time. Typical thermoplastics that we have, well, most of us have probably been through, our S1 course where we still use acrylic. You see there it's got properties and it's got uses there as well. Acrylic's one of these overused ones. People, it's not my go-to answer. Okay, if you were to say to me what would be an answer that would answer maybe 95% of questions in an exam, acrylic would not be one of them. But you do need to know what it is and where we use it and why we use it. And it can be used in a number of different reasons. You've seen the colour stuff that we have. We could use it for splashbacks, you could use it for countertops. There's a number of different areas which it can be used for, and you can see there with the signs, lenses, jewellery. Colour is the main thing with it. Acrylic comes in many different colours. You can bond it together to create thicker sheets. There's lots of things you can do with it. My normal go-to answer for plastics is going to be ABS. Now, ABS is not its actual name, it's the shortened version. I'm not even going to try and do it and say it. It's quite long and quite difficult to pronounce, but you just need to know the 3 little letters. And that's a good thing with plastics. Most of the time it is acronyms we are remembering. So ABS is one of the most used plastics out because it's really strong, it's really hard wearing, you can bash it, batter it, and it's very difficult to actually break or do anything to. It's also really good because it's chemically resistant, so cleaning materials or lubrication materials will not affect its performance. So you see there that it's used as toys. So little sit-on toys, anything that kids want to bash around, kitchenware, plastic furniture, crash helmets, cases, and again we will go through lots of questions and show you where ABS is picked up. If we get on to things like plastic bags, bottles, cable covers, LDPE, low density polyethylene. So it's a soft material, flexible. So plastics don't have to be rigid at times. Plastics are also quite soft. So a good electrical insulator. When it says plastic bottles, it's specific kinds of plastic bottles. Okay, it's more your plastic bottle which is going to be single use. Okay, it's not going to be something which you're going to use on a regular basis. That would be its friend, which is HDPE, which would be high density polyethylene. Nylon. Now, nylon is one of these plastics which is extremely hard wearing, extremely tough and resistant to wear. You won't physically see it that often, but usually it will be hiding in behind things and mechanisms and stuff, hence why it says there gears, ropes, bearings, clothing. Yes, clothing. I'm sure we've all come across nylon in clothes and stuff. So it's hard wearing, and again this is the one thing we are saying, you talk about something hard wearing and durable, but you've got clothing in there which is soft and pliable, but it's still the same material, 100% nylon. We'll come to that in a wee second with some of the explanations. Polystyrene, sort of thing that you get in your food packaging, containers, games, DVDs, protective packaging. Normally people, when you say polystyrene, it's the great big white bits that protect your TV when it gets delivered, your fridge, your freezer, all this sort of stuff, and it's the wee balls, and if you look carefully into it you can see how the individual granules have kind of fused together with each other. But again, it comes in different ways, and your food packaging is a perfect example. Nearly all your food packaging will be polystyrene. Polypropylene, light, rigid, chemically resistant. Medical equipment, rope, kitchenware. You see the crossover there, it's starting to get some crossover with plastics here in terms of what they're used for. So it really depends on the application, and this is why there's multiple correct answers when it comes to answering questions. There's our friend HDPE, wheelie bins, buckets, bowls, containers, detergent bottles. These are things which are thicker in terms of the material. Your sports bottle where you drink on it on a regular basis, you want that flexibility to squeeze it, but you don't want it to break. If you take a juice bottle, a one-off one, like a water bottle of water you've bought from the shop, once you've drunk out of that, the bottle squeezes and that, it doesn't go back to its original shape, whereas your HDPE will return back to its original shape time and time again because of the nature of the composition of the plastic. Just while I finish on it, those are the sort of the main ones that we need to know inside out. When I say inside out, I'm not sort of looking and saying that you need to know it's for this, this, this and this. There will be go-to answers, 2 or 3 go-to answers which I'll give you, and you'll always be correct if you give them. Okay. What we need to know is the properties, why we are using those plastics. Is it because it's light? Is it rigid? Is it resistant to something? Those are the main things that we've got to think about. The thing that makes those plastics there different from each other are effectively what we add to the actual plastic composition itself. So elastomers, this is one of these things when it comes to those into chemistry and stuff. Elastomers are things which we can add to the materials which make them more flexible, more rigid even, change the properties of it, how the light goes through it. So, you know, they're things which will make the plastics a different, in a different way, even though it's still the same name. You know, acrylic as well, it's another one of these ones where it can be used for clothing, where it's 100% acrylic clothing, but acrylic, I can show you acrylic where it's a hard piece of plastic in the workshop. So, you know, it's these things which we add to make things different. Don't need to know too much on elastomers, to be fair. The other plastic we have is a plastic which we can only heat it up once. Okay, so we always use heat to form a plastic. Once we've actually formed that plastic as a thermosetting, if you take heat to that again, then it will just reduce itself in a number of different ways. It'll either just melt, or it will smoke, it will burn off, it will flame. So these are a once only use. Where would we see these? Well, typically I'm sitting here in my little kind of study office type room. I'm looking my television, the casing round the outside of my television is probably a thermosetting plastic. It's a once-off use. Why? Because it doesn't conduct electricity and it doesn't transfer heat. It's able to absorb a lot of heat without misshapen. If you think about a thermoplastic, where we use heat to reshape, if I get too much heat in this, the last thing I want is my TV heating up and then actually the shape of the frame warping or changing composition. So thermosets are good for things like that. Wall sockets, light sockets, where they don't conduct electricity but they are able to withstand huge amounts of heat without actually doing anything. And again, in the workshop we'd be sitting here with a bunch of plastics in front of us. We'd have the forge on, we'd have my iron on, my gas on, and we'd be burning stuff to see what actually happens with these, to demonstrate the abilities of these. So they do have the strength thing. They can be broken quite easily, that is one thing, and again with a hammer we would show you how they would snap and break in terms of that. Typical ones with these are our formaldehydes. So the ones we need to remember, these are the only three that we really need to remember on this: melamine, urea, formaldehydes, both formaldehydes. You can see there from the uses there and the properties, they have specific properties which you can link to products. So the lamination of worktops, the desks that you'll be sitting at back in the classroom, melamine formaldehyde is the veneer that's on the top of it to protect it, to make it scratch resistant, make it last a lot longer. Again, buttons, electrical insulation, electrical fittings, you can see why here, heat and electricity. So anywhere where we see that, these are the two good ones to use. Epoxy resin can be used as a glue. So we talk about Arodite as a trade name for epoxy resin. So it can be used as that, but epoxy resin can be used itself. If you mix a two-part material, you will get a hard plastic, which is extremely hardware, and again I can show you some things on the computer once we get back into class on that. But again, we just want to remember these three that come from here. I'm not going to do composites today, we'll save that for later on in the course because I don't want to complicate matters. So plastics, thermosets and thermoplastics. That's effectively all we really need to know, and the two tables there are the ones that we want to pick up on. Now, how do we use this information? I'm going to give you a quiz again, but it's not going to be like a multiple choice quiz. We're going to change it a little bit more towards how the exam stuff's doing. So I'm just going to flip across here to... Okay, so you'll see here, I've now got a typical question. This is from one of the exam papers from a number of years ago, and this is what you guys will be seeing is you will have two products here. Two similar products. They both do the same thing, but they're both significantly different from each other. Not too worried about, trying to explain everything about these just now. Question A though, it says, explain why the materials chosen for each of these products are suitable. Now this is the thing I'm kind of looking at. So we'll do a little basic introduction with some simple stuff to get you writing some stuff, and then I have Miss Blair, and you'll get her dulcet tones explaining to you how to write a correct solution to this as well, rather than me redo what she's done. So if we are looking at here, looking at the materials, everything we do with materials is to be able to pick a material for ourselves. Most importantly is to explain why we have picked that material. What were the reasons for it? And that's the things in those tables there where it says advantages, disadvantages. That's what we're looking for. So if I was going through this, we've now done metals, woods and plastics, so we should be able to look through here and link to a lot of the materials that we've got here. If I was just to pick here 6 materials, so in my Wheel Easy collapsible here, it has a material here, mild steel frame. So that's this little bit that's going round the outside round here. So up and down here, the handles, and it says tubular. Well, when it says tubular, that means it's hollow. And it says here, explain why it's suitable. So you have to give more than a one answer. But why is it suitable? I always think back, I've got a little thing which I'll give you when we get back to school as well, a little wheel of fortune which gives you every answer that's possible for this. But the easy one you should be saying to yourself here is, well, why have I used steel? Right, okay, what is the one thing I'm doing with the product? What does a person do with it? You're going to put stuff in here which is very, very heavy, or could be heavy, and you're going to lift it. So if you're going to lift here, then the first thing you need to think about is the strength. Tubular steel, tubular mild steel frame is suitable because it offers strength, which allows the user to put a lot of material into the wheelbarrow. Now, I could have just says strength. Steel frame is strong, but we're not looking for just a simple answer. We're looking for the extended answer, which gives us the reason, and then you're relating it back to the product, how the person's using the product, or how that part is relevant. So it's the strength to allow more material to go into it, to allow it to become or transport heavy materials. That's why it's the steel frame. If I look down here, let's go to the second one here, the endurance. So if I said the polypropylene handles, so this is little black handles that's on here, why have we used these? Give a reason for using these. Okay, so what would you'd be doing? Go back to your table and say, right, polypropylene, what is it about polypropylene? Well, polypropylene is quite a soft material. It can be made soft. So if the person's putting their hands on here, the last thing you want to do is make it uncomfortable. If you're using this on a daily basis, back and forward, so you might be a construction worker, might be using this for 2-3 hours at a time. If you just had bare steel on there, think how it would be on your hands. It wouldn't be very easy to hold, but also be quite uncomfortable. So the handles are there for two things. The polypropylene is there because it gives you additional grip, which means it's easy, which is less likely for the person to tip the wheelbarrow over. It also makes the handles more comfortable, which allows the user to use the wheelbarrow for a prolonged period of time. So you can see there the answer is twofold: the reason for doing it and how it relates to the person using the product. And that's what I kind of want you to do with the little quiz that's coming up. It's a written example. So there's two things to link in there. These are great, by the way. You know, you can go back. We do lots of these if we have to. I don't know the structure of the assessment next year yet, but let's hope, you know, if my thinking's right, there may be a shortened exam, and a lot of it might be classwork, which is me providing proof of what you are able to do. A bit like prelims, but maybe a little bit more extensive in terms of how many we do and how often I do it. And this is the sort of thing that we'll be doing, is looking at questions like this and relating the materials to the reason for actually doing them. So I'm going to set that little quiz. I will pop on the whole of the PowerPoint for you. So I'll actually put on this. I'm going to leave the composites in there. You can go read it if you want, so you can go and have a wee nosy at that. But this has our woods, metals and plastics that we've been doing, so that's a slide format for you to go back and look at. So the quiz itself, the format of the quiz, so you'll see here, state and justify the most important material requirements for the bottle opener. So the state is, what is it? So that would be kind of the, and don't just write single words for these. I like to see things written in English sentences. It's a higher you're doing. It's not, you know, National 5 where one word answers are acceptable. So your answer would be, you'd say that a suitable material for this would be whatever material you decide. Okay, and then you would explain why. So the justify is giving reasons why that material is suitable, and you know, there's a number of reasons you can use different things. Use the internet to research if you're not sure. Use the notes to research if you're not sure. So again, coming down, state and justify the most important requirements for the outer casing of a hairdryer. Think about how the product's used in real life. So there's not a huge number of questions. There's only 4 questions in this little quiz, but they are extended answers, so I'm not looking for one-word answers in the quickest solution. Try and think about your answers and how they would go. In terms of the last one, the reason I've changed it is you're obviously getting the material stuff no problem. The last quiz was done pretty good. Okay, while it might have showed a wrong answer, sometimes it was just because you're spelling, or maybe it wasn't quite matching my exact answer. I had to look through them all pretty good. Okay, so I'll leave that for you to do. I'll give you that till obviously we're second last week of term. You had a freebie yesterday because I was in school, so I think I'll just set this for Thursday to give you a bit of time to read through this and then answer it into a decent standard. Okay, so I'll check in again and I'll make that for, let's make that for Thursday at 4 o'clock, I think. Okay, enjoy the rest of your couple of days. Enjoy reading over this. This is us starting to get into the way that it's using the information, so hopefully you'll get a little bit more feeling that you are connecting with the subject.